Everyone, welcome to our first webinar on tracing. I have here with me Eben, our tech lead, who has been driving the tracing project forward. And first, we will run through a demo, kind of show off what Honeycomb can do and how tracing fits into the big picture. And we'll open up the floor for questions. All of you are panelists, so you should all be able to raise a hand, ask questions. And at the end, we'll have some questions for you about what sort of follow-up content you'd like to hear. So with that, Eben, take it away.
Awesome. Hi, folks. I'm Eben. I work here at Honeycomb on the tracing feature and some other stuff. And before we get started, can everyone hear me okay? This webinar thing is new to me, so I hope I'm not just shouting into the void. So like Christine said, what I'm hoping to do today is show a little bit of how tracing works in Honeycomb, some of how we've used it internally to try and make our own service better, talk about how you can get started and answer any questions you might have, and maybe talk about some things that we see on the road ahead for this feature. Does that sound good to everyone? Take that as a yes. So let me dive right into a brief demo of how tracing works in Honeycomb. And if you're already familiar with Honeycomb, or you're a Honeycomb user or customer, some of this will seem pretty familiar. If you're new to Honeycomb in general, I hope this will also give you an idea of some of the other things that Honeycomb tries to help you do. So what I have here on my screen, I want to share my screen. How's that? Sweet. What I have here is the Honeycomb Query Builder, which is a way to ask questions about data that you send from your own services and infrastructure to understand what's slow or broken, what users are making requests, what they're doing with your product, things like that. This data set is composed of events that you send. So each event is essentially a structured JSON blob that has a bunch of different fields. So here we can see an example of what fields we're sending. There's a timestamp, a duration, a name identifying the sort of operation that we're doing, some metadata, and IDs that are either unique to a trace or unique to a span within a trace. And in a minute, we'll see how those are useful. This is a little abstract, so let's dive in and start asking some questions about this data. The first thing I might want to ask is, okay, I'm running this web service. What events are slow? And I can do that with the starter query here, just diving into the slowest traces in this data set. So what I'm doing here is running a query where I take the maximum duration. I want routes of traces, and I want to run this over the past 2 hours. And I get a nice little time series graph that shows, okay, typically events take no more than around 600, 700 milliseconds. And then somewhere in here, there's a latency spike where events take up to 1.5 seconds. I want to dig in and find out what's going on. So one way to do that is with Honeycomb is to start dissecting this data and ask questions like, what endpoint is being hit? Are all my endpoints in the service particularly slow? Is it just one? Is it one user who's making particularly slow requests, and so on? I do that by adding breakdowns. So I can break down by, let's say, endpoint shape and see, okay. For example, we have an API service that has different API endpoints that it serves. And most of them, the maximal latency is fairly constant. However, this particular endpoint, the API v2 tickets export endpoint, is exceptionally slow over this 20-minute window. So let me dive in and figure out, see if I can figure out why this particular endpoint is particularly slow in this particular time interval. So let me just filter down to show only the maximum duration for that endpoint shape. And now I can maybe start asking questions like, how much time did we spend talking to MySQL? How much time did we spend talking to our fraud service? If you've instrumented your code with timers, you can start to get an idea of what might be going wrong. So this picture shows pretty clearly that the problem seems like it might be rooted in MySQL. We've timed our code so that we're measuring how much time we spend talking to the MySQL database. And we can see that the MySQL latency is rising in concert with the total latency. However, this now is where we get stuck. If all we have are a few coarse-grained timers in our code, we don't understand, which queries we're running, where in the code these queries are being issued from, and so on. This is where tracing can be a big help. I can say, okay, let me not just take these aggregated metrics from my service, let me actually look at a slow trace and see if I can get a picture of what's going on. In Honeycomb, you do that simply by choosing an interesting point on the graph. Like, let's choose a point up here where the requests are slow, and click through to see an example trace from that time interval. Now, instead of just looking at metrics, we get a trace, which is a picture of the execution history of our API requests. We start in the API service, we serve a request for a particular endpoint, and then in our service, a couple different things need to happen for us to actually serve a request. Maybe we check rate limits, maybe that rate limiting request hits some sort of cache service, maybe we authenticate the user, and then maybe we call out to some sort of backend service to actually construct the data that we want to return to the user. This picture makes it really clear what's broken here. We have this ticket backend service that has a method, fetch tickets for export, and it is doing a lot of MySQL queries. And so that's why we're spending a lot of time in MySQL. That's why that particular endpoint is slow. We can also look at a particular span in this trace, and in the sidebar, see metadata for the span. All the tags that you've attached to the span, all the fields that you put in your Honeycomb event. If you're like me, you might want to move your little zoom widget off to the side so you can see the query details on the side here. We can see that we have a timestamp, a duration, an ID, and the actual shape of the MySQL query that was issued. Okay, so this is interesting. We're issuing a query here, and we're doing a bunch more queries. Are they all the same? Let's click on a few. It looks like they're all the same. That's suspicious, huh? We can confirm that hypothesis by actually taking the query fields and putting it in the column, and now it's immediately clear, wow, we're doing a bunch of basically the same MySQL queries. This is obviously an egregious performance problem that we can maybe try to fix by issuing a single, more performant query, or doing something else to make this API more efficient. Does anyone have any questions so far? It's so quiet. All right. So what you've seen here is that Honeycomb tracing helps you take events from your service and get a picture of what all needs to happen for a request to be served or something to happen in your distributed architecture. This is pretty helpful if you're new to a company and you want to understand just how does this thing work. Instead of spelunking through code or asking people, you can go look at this picture of what's actually happening. You can take this, and if you're on call, it makes it a lot easier to understand which component is broken and go right from a page or a metric to an actual point in code and figure out what needs to be fixed. So we think that's pretty powerful. The other thing that I want to highlight is that tracing is pretty integrated with the previous Honeycomb experience of computing arbitrary aggregates over your data. A problem with a lot of tracing products is that you can look at individual traces, but if you find an interesting trace, you can't really understand whether it's representative of the overall health of your service or not. Maybe you're looking at a trace that is an outlier, maybe you're looking at a trace that is typical. How can you really understand that? And to illustrate that, I want to show not just the CAN demo, but a little bit of how we internally to Honeycomb use tracing to make Honeycomb the product a little better by switching over to one of our internal data sets, which is instrumentation from Honeycomb's own query path. So if you log into Honeycomb and you run a query, we collect a bunch of instrumentation to try and ensure that we provide a performant experience for you. And so this data set contains traces from the query path. And these are, as you'll see, are quite a bit more involved than sort of the demo trace. What I have here is all the queries that were run over a given time interval of about 2 hours. And we can see most of them are pretty quick, sub-second, and then there are a few that take more than a second. We might want to understand why that is and whether we can make them more performant. So here's an example. This particular, we can see here there was someone ran a query and it took 1.2 seconds. What happened? Why did it take that long? I can just click through and see in a second the trace. And as you can see, this one is quite a bit more involved. There's a lot of stuff going on here. And this is pretty typical. As you add more instrumentation, your traces become larger. But we can sort of collapse this and start to see some interesting things. So one thing that's interesting here is that one server appears to be about 0.7 seconds in the future. That's interesting, isn't it? Maybe we should synchronize our clocks more closely. Another thing that we can see is that if we collapse this, this query took 1.19 seconds overall. It spent 25 milliseconds fetching data and 1.1 seconds persisting results, so that if you want to go and look at the query later, you can see the same results that you did. Now, as an operator, I can ask, is this typical? Does persistence usually take upwards of a second? Is this a big problem that we need to fix? Or is this particular trace like kind of an outlier? You know, maybe something went wrong just once and we don't really need to worry about it just yet. A good way to answer that question is to back out to the query builder and say, okay, I'm interested in specifically in asking about events of type persist, and I want to ask for the maximum duration and maybe something like a heat map of duration. So you can say, okay, how long do these typically take? And let me back out to a longer time interval, the past 2 days. And we can say, okay, it is the case that we have a few of these spans that take upwards of a second, 2 seconds, as much as 2.7 seconds. But if we look at the heat map and the little histogram, typically they take much less time. And so now we've gone from a trace, a hypothesis about something that might be wrong, to a picture of whether that's typical or not for our service. And this lets us make smarter decisions. Maybe because these persist spans that take more than a second are really relative outliers, maybe we don't need to prioritize addressing this, or maybe we do, depending on the SLA that we want to make for our service. And so we found that the ability to switch back and forth between heat maps, time series, and individual traces has been pretty helpful in understanding how our services work, formulating hypotheses about things that might be broken or not, and then confirming or disproving them. So if we're on call, we can go from a page right down to an example broken request and pretty quickly isolate a broken code path. Or if we're just trawling for general performance improvements, we can quickly find areas of improvement without spending a bunch of time on hunting in the dark. That's mostly what I wanted to demo in the UI. Again, I'd like to open it up to questions if people have thoughts, ideas, other things they're curious about from what they've seen so far.
If there are no questions, I'd love to hear from you all. What were you hoping to learn in this demo? What would you like to understand a little bit better about how Honeycomb thinks about tracing? What sorts of things folks can do with tracing in Honeycomb?
I had a question. This is Branislav from Fender. I was curious, how did you set up instrumentation for these examples? Since my experience with Honeycomb, I didn't know that we can do instrumentation this way.
Mm-hmm. That's a really good question, and that's actually a fantastic segue into what I was hoping to talk about next, which is how do you instrument your code to use tracing? The short answer is there are several ways. Which way is most appropriate for you depends kind of on where you're coming from and what you're trying to accomplish. I think one thing that we saw in building out this product is that a lot of solutions couple instrumentation with the UI, and we think that that's kind of a challenging way to approach it. A lot of products support open tracing, which is a language API for instrumenting your code. But in order to use them, you must instrument your code with open tracing, which is often a big hurdle to people getting started. So if you do use open tracing, we have an answer for you. But you can also take your existing structured logs, augment them with a few distinguished fields, and then you'll get tracing in Honeycomb simply by sending your logs to Honeycomb or using Honeycomb's SDK to send events. So if you're already using open tracing, a solution we provide for you is what we call the Honeycomb Open Tracing Proxy, which is an open source library, a little binary that you can run in your own infrastructure. And as this diagram shows, hopefully you can see this diagram here, it acts as a mediator between the instrumentation you send from your services and Honeycomb's API. So you use an open tracing library to send spans to the proxy. The proxy takes care of things like authenticating with the API, sampling, throwing out sensitive fields that you might not want to send, and it transforms the Zipkin wire format that's emitted by certain open tracing client libraries into JSON and sends it to Honeycomb. So if you're already using open tracing or you want to use open tracing in your code, this is a good way to do it because you can use these very sophisticated client libraries to propagate context between lots and lots of microservices and send all that data to Honeycomb. However, it's a big hurdle to get started with if you haven't used tracing at all before, but you already have something like structured logging in your code, which is more common. So if you don't want to use open tracing, all you have to do is add a few distinguished events to your data. And they're described here in the docs in the manual tracing section. Your data just needs to contain a few distinguished fields. In particular, every time you generate an event, a log line, you generate a unique ID and possibly a parent ID. So the parent ID and ID together define the graph structure of the waterfall diagram. So for example, if you start with a root event that's an API request, and then you have a child event that's, say, talking to the cache, you make a new event for talking to the cache, give it a unique ID, and this parent ID is the ID of the root event. Finally, all events in a trace should have a common trace ID. So to make this a little more concrete, let me just flip back to a particular trace and show what this looks like in practice. So here we have a root event, which has, down here on the bottom, almost obscured by the trace widget, it has a trace ID, and it has its own ID. And then its children have a parent ID and the same trace ID. So all events in the trace are related only by having a common trace ID. And so this way, you can start with whatever logging you have and turn it into something that Honeycomb can build traces for simply by adding these extra fields. And that's a pretty good way to get started. However, if you're not using Honeycomb already, you don't really have structured logging, and you're not interested in open tracing, a quick way to get started is with Honeycomb beelines. Honeycomb beelines are libraries for, Go, Ruby, Node.js, and soon for other languages that are pretty much drop-in libraries that you can add to your service, and they'll emit basic traces for individual services. So if you don't have much instrumentation already, you just want to get started, the beeline is a really easy way to go from nothing to pretty good insight into your service very quickly. So in short, I guess the answer is there are different ways. Whichever way works best. Depends a little bit on the context where you're coming from, whether you have a startup that you're just trying to get off the ground or a really mature infrastructure that would benefit from investing time in instrumenting everything with open tracing, running a proxy, and getting really deep insight. Do people have questions about this, about the details, things we should dive into a little more specifically?
Yes, this is Michael from Fender. I have some questions on how does tracing work in conjunction with sampling?
That's a really fantastic question, one that we get a lot. The short answer is, well, actually it's not a short answer. The answer is B-lines as well as the Honeycomb proxy sample traces rather than spans. So this is actually called out in the docs, which I happen to have right here. The way this works is basically using a sampling algorithm where given an event, you take the trace ID, hash it to an integer, and then say if that hash modulo n is equal to 0, we send the span. If not, we drop it. This might seem a little abstract, but the net effect is that either we send a complete trace or we drop a complete trace when we're doing sampling. And so you don't end up with weirdness where you have a trace that is randomly missing spans and you can't really figure out what's going wrong. But statistically, the effect is the same. And so because aggregates and Honeycomb correct for sampling, things like count, latency metrics will still be statistically pretty accurate, even though you sampled by trace. This is actually pretty similar to how some other libraries out there, like the Jaeger client libraries, do it. The key idea is basically just you sample by trace ID rather than making a fully random decision. The B-lines do this, the proxy does this, and it's pretty easy to do in your own code as well. Does that address your question?
Sort of. I mean, we're all server, so that, and we do some more complex sampling to where like info and 200 stuff are all sampled, but errors we don't sample at all. So I would assume if we wanted to just sample regular traces, I think we just use the regular Go library that we have all our logs going to a single function that we then sample and publish to Honeycomb, that we would have to somehow mark those traces as being associated with an error condition so that they wouldn't be sampled. Is that accurate?
Mm-hmm. Yeah. Mm-hmm. Yeah, I mean, it's...
So we'd be looking at possibly like aggregate, like sort of collecting that sampling data until we get to the final end result of the transaction as to whether or not it's good and whether or not we should sample it or definitely want to keep it.
Mm-hmm. Yeah, I mean, there are a couple of different ways to approach more sophisticated sampling. One is to combine a static sampling policy. I'll just do one out of every n traces with some distinguished logic. If a span has an error or some sort of distinguished tag, we'll always keep it. Ultimately, if you want to get really sophisticated, you kind of, you might be best served considering the proxy approach, because that way it becomes possible to sort of buffer spans in the proxy and then make a sampling decision at the end. And while the proxy doesn't quite do that yet, it's on our near-term roadmap to support that sort of thing. And so introducing like this middleware layer makes it much more possible to do more sophisticated sampling decisions. And we also recognize that that's kind of challenging and are looking at ways that we can actually do this in the Honeycomb API to make it much more tractable for our customers. You just send everything, and then as long as spans are buffered somewhere, you can make more sophisticated decisions about whether to keep a trace or not. But in short, the quickest way to get started is static sampling plus, oh, the span has an error, I'll keep it. And that actually gets you a lot of insight, even without getting too sophisticated. Does that make sense?
Yes, it does. Thank you very much.
Were there any other questions, things that we should be digging into more about how to get started, what you can do with this?
All right. In that case, we will give you your time back early. I am launching a poll to find out if folks have any additional questions. It seems like it is a poll that is only visible by attendees, and somehow.
Oh no, we're all panelists.
All right, well, I'm moving folks. Cool. All right. I'm sorry for the moving folks around. We'll get better at this in the future, but Now attendees have access to this poll. We're happy to keep playing with this format, and we love hearing from you what you want to know more about and how we can be more helpful. So please, thank you to everyone who's entered the poll. If anyone has some colleagues who wanted to make this webinar but couldn't, I believe we're recording this, and so we should be able to capture this, send this out, and make it available to anyone who wanted to attend but couldn't. All right. I'll leave the poll up for a little bit longer. Thank you to everyone for joining us. Have an excellent Friday.
Yeah, thanks, folks. And of course, if you have questions or thoughts, you can get in touch with us by a multitude of methods, including the chat widget on our website, emailing support@honeycomb.io, the Twitters, whatever floats your boat.
Great. If you don't hear from us, or we didn't get the recording to the right person, feel free to email support@honeycomb. We'll make sure to direct the link to the correct address. All right, thank you so much.